Welcome back, everybody. The topic of this video is cache designs. We'll focus on the first one that we'll be talking about, the direct mapped cache design or cache organization. The best way to talk about cache designs is within the context or framework of answering these four questions. Where can a block be placed in the upper level in the cache itself? How is a block found in the cache? Which block should be replaced on a miss? And what happens when I write? A block is a single entry or a line, also known as a line, inside the cache. So the first question is, where can a block be placed in the upper level? Based on how you answered this question, you would be referring to one of several different cache designs. The first one that we'll be talking about is the so-called direct map. Direct map is, as its name says, a memory address maps directly to only one unique location inside the cache. So, for example, in this example, the main memory is a memory that has 32 different entries. The cache is a memory that has only 8 entries. Therefore, anytime when we fetch and bring data from different addresses from the memory into the cache, we will have to map directly each of these addresses to a unique location inside the cache, because we have many more entries inside the main memory and few cache entries. We'll definitely have multiple memory entries mapped to the same unique location inside the cache. The way we would do that mapping in the case of the direct map cache designs is by using the modulo operation. In this case, mapping the data from the address 12 from the main memory and into the cache, we'll find out that the cache entry index 4 is given by 12, the address from the main memory, modulo 8, where 8 is the total number of entries into the cache, and that is 4. So the data from this address maps to the cache entry address 4. So here is another look at that same example that describes the direct cache design. So a location inside the cache is determined by the address of that data from the main memory, and as you'll see here, using that modulo operation, multiple entries from the main memory, the gray ones over here, map to the same cache entry index or number 001. The way that is achieved, this modulo operation, is to look at a given address, for example, 010001, take the least significant 3 bits, and that is the index of the cache entry where that data will be fetched and placed into the cache. Only the least significant 3 bits, because 3 bits are enough to be able to index and refer to each of those 8 entries of the cache. 2 to the power of 3 equals 8. Now the second question that one can ask about a cache design is how is a block found if it is in the cache? And let's look at this example over here of a cache design that has 1024 entries, and it is a direct mapped cache design, meaning that the data from the main memory maps directly to only one unique entry into the cache. But because multiple different addresses from the main memory may map to the same cache entry as we saw, the question is how would one be able to tell whether the data that exists in that cache entry is from one memory address or from another, that both of which would map to the same block or line of the cache. So in this diagram, we would have here the address of the data that from the main memory that the processor is asking about, and it illustrates and shows how exactly this 32-bit address is split into several different fields and used into finding out the answer to this question. The first 2 bits, assuming that we are working with a byte addressable memory, are always allocated to be able to index the bytes within a given word of 32 bits. So just ignore that for the time being. But after that, the least significant bits, as we saw over here from the address of a memory entry that maps to a certain cache entry, are utilized, as we saw on the previous slide, to index that many entries of the cache. And because this cache example has 1024 different entries, we need to allocate and use a field of the least significant 10 bits from the memory address itself to be able to index all of these different cache entries. Now, so that's fine. We can use these 10 bits to be able to index and find out each of these entries and of the cache to which the data from this memory address might be mapped to and located inside the cache. However, to be able to say whether that data from this cache entry comes from that particular address, the way this cache direct mapped cache design is organized and constructed is that inside the cache we also store some additional information called tag. And what that additional information is the most significant bits from the memory address that the data that is mapped to this cache entry or cache block comes from. Therefore, when the processor is asking about whether the data from that memory address is cached or not, to find out the answer to that is you use this 10 least significant bits and find out the entry, the index of the entry into the cache where that data might be located. Check to see if the tag is the tag of that comes from out of that address. And if that is the case, then you will have this comparison here giving you a logic 1, but there is something more, a check on so-called valid bit, and if that is logic 1, if it's true, then that will give us a logic 1, and that translates into the cache design telling the processor that yes, it is a hit. The data from this memory address is valid, is coming from that address because the tag comparison here gives us true, and the data will be located here. It can be retrieved and passed to the processor. Now the valid bit here is just 1 bit and is necessary to simply signify whether the data, the block, this entry of the cache is valid or not. Remember, when we power up for the first time the processor, all the cache entries will be empty. They will not have any useful real data, and all the valid bits will be 0. As the processor asks for more and more data from the main memory, data blocks will be fetched and placed into the cache, and when that happens, the valid bits are turned to logic 1. So that's how a block is found in the cache designed for a directly mapped or direct mapped cache design. Now, which block should be replaced on a miss? So when in the previous case, the processor is asking about the data from a main memory address that is not cached, it doesn't exist, and the cache entry at that location, then that is a miss. In that case, the cache controller talks to the main memory controller and requests for the data from the main memory. That data, that block, will be fetched and placed into the cache, into the cache entry that is unique in the case of the direct map. So when a new block is fetched, it's very easy to answer the question. Is going to just overwrite whatever data, whatever block is already in that unique location where it maps according to this direct mapped cache organization. In the case of the set associative or fully associative cache designs, which we'll talk in the next video, that is slightly different, and we'll talk later on about that. Finally, the fourth question in talking about cache designs is what happens on the right. And there are two main popular cache designs. One is the write-through cache design, and the other one is write-back. The write-through cache design or organization is when the data is written to a cache block by the processor, it is also written to the lower level of the memory. For example, cache level number 2 or to the main memory. But remember that always takes many more clock cycles. It's slower, and waiting for the data to be written into the cache as well as into the lower memory will always have the penalty of long waiting times. The write-back cache design or cache organization is when the processor writes the data to the cache block. It is written only to the cache block itself and not to the main memory. That data will be written to the main memory or the lower level of the cache hierarchy only when that block will be have to be replaced, will be overwritten by new data that will be fetched and placed into that cache entry. So to summarize, the direct map cache design is a cache design where the block can be placed in the cache to only one unique entry location. The block is found by also checking on the tag and the valid bit in the cache entry to which that memory address maps uniquely to. Which block should be replaced on a miss? That's very easy. There is only one block because there is only one location where the data from a certain main memory address can be placed to. And the final question, what happens on the right? It depends on whether you are using a write-through or a write-back cache design. So that was the direct mapped cache organization or cache design.